for the introduction, Min. I do appreciate it. There's probably a few things that we'll talk about, but depending on how controversial the talk will be, so I'd like to get a bit of a sense for the room. So first sort of show of hands, who thinks that testing in production might be a good idea? Cool, what a forward-looking group of people we are, my goodness.
My production or someone else's?
Oh, it's always someone else's. And who's actually doing it? Security, we found a couple of people down the front. What I want to do today, though, is take you on a journey, maybe not so much for people in the room, but a few people maybe back in your organizations as well, and seeing maybe a little bit of the reticence or maybe a bit of the fear that might come from testing in production. So one of the things that I want to do, though, is dispel a lot of the stigma that is associated with that term. So get a common understanding for it. From there, we'll also look at what are some of the barriers. So in the same way as a roller coaster, how high do you need to be? Like, what capabilities do you need in your organization to be able to take advantage of these techniques? And then we'll actually see some of what we'll actually do, some of the techniques that comprise the umbrella term testing and production. I will see them in action. And mainly, it feels like a really good sense in the room. But after this talk, like, feel free to come and chat to me, because this is something that I'm really passionate about, and I think there's a huge potential for all of us to deliver value quicker. So first question, why do we test software? Many reasons. You could say, well, we want to validate that we're going to achieve the business outcomes, that it does what we want it to do. We could verify that the behavior does all the non-functional aspects, and all of these other aspects as well, but really, we test to gain the confidence required to ship code. That's all we do. Testing is not the purpose. We're here to deliver value to customers, and testing is a means to an end. And that's exactly it. So again, the product that we show to our customers, they don't actually care that we've TDD'd it. They don't care that we've stayed up all night crafting this incredible test suite. They don't see that. That is all under the water. So to put it another way, they do not care at all about how we have made that quality product. They absolutely care about the quality, but the journey to get there, not so much. So based on that, the takeaway is what we're looking to do with testing is attain the confidence to ship a release to production as quickly as possible. That's the means to an end. So what we want to do is we want to do that with the absolute minimum of effort. If we expend any additional effort that we need to, then that is waste. So what is effective testing? So effective testing highlights false confidence. So in many cases, we're trying to say, do we have enough confidence? But we could spend 3 days testing a release, and if we don't find any issues, does that mean there's no issues? No, what we want testing to do is actually find an issue that is likely or very likely to occur in production. And then, even better than effective testing, what we want with efficient testing is how do we do that as quickly as possible, minimize the waste. And that's the rub with testing. Like, a lot of effective testing is predicated on running the code in an environment that as closely mirrors the context in which we'll run in production. That's quite often for us not the case. We have these test environments that can look dramatically different, both in scale, data, size. So we can spend a lot of effort testing systems that, in fact, the environment doesn't look anywhere near like it will in production. And distributed systems, we're no longer building things on the LAMP stack anymore, are even more resistant to being able to be cloned in test environments. So the scale could be massively different. So is your test cluster really a cluster, or is it just a single machine masquerading as a cluster? So what about traffic volumes? Is it even representative? Is it just a scaled down version? Is it even traffic that looks like production traffic? So even if you manage to record your production traffic and replay it against the test environment, is that really going to give you the context? See, there's so many other variables as well. And likewise, data. So even if we're doing a simple database, and if there's very little data there, maybe a table scan is actually what we want from a query execution plan. Suddenly you put that into production data, with tens of thousands of millions of rows, that will perform terribly. So while these facets around expense, cost, time of creating accurate test environments, to be honest, if we're talking about this though, that's part of the problem with environments, because testing is not worthless. Absolutely not. It creates an incredible amount of value, and it gives us a huge amount of confidence, but to a point. So what I want to land in this question is leave you thinking, where can I draw the line for the products and the applications that I build and I release? I'll clearly put my hand up here. I actually think as an industry, we spend far, far, far too much time testing our code in test environments. Far too much effort. And because we've kind of grown up in this dogma of if you catch a defect early, then you're going to minimize the cost of the impact. If it goes all the way to production, that could be 10x the effort. What we don't see in that, though, and here's the rub, is the cost of actually finding one of those defects. And for distributed systems, actually to find an issue that might actually occur in production can take a huge amount of effort. So again, think about what we've been taught growing up and say whether it really applies to the systems that we're building today. And many of the practices that we do for testing our products are absolutely horrendously inefficient. So if you have a release cadence of once every 2 months, what might happen? You will get your entire team, and we're going to do a bug bash day, and we're going to spend hitting all the manual tests and everything from there. And at the end of it, we probably haven't found much, have we? But what this does give us is this wonderful security blanket. And we can say, well, if something goes wrong now, we've done everything we could. Like, we're in the clear. Like, it's time for harsh truth. You really haven't. You haven't at all. All you have done is the most that you could do within your current approach to testing. But you are constrained by that model. You need to change the model. We need to change the model. And this is because testing is a best effort verification of system behavior. It is not extensive. We will only discover something that we specifically test for. We want to check if this behavior is accurate, that's fine. But what about the myriad different behaviors? So if we're talking distributed systems, many different nodes, possibly across different data centers, these systems can fail in myriad different ways. How much confidence can we really get from testing at one point in time with a particular data set, with a certain set of users at a certain traffic volume? Not that much at all. We simply cannot predict all of the failure cases that we will see in production. And in fact, if the conversation in your company is, how do we get a more accurate or representative test environment, you are missing the point. That is not where we need to go. The answer is not trying to get a more representative test environment, because that will not scale. Imagine that was Facebook. Like, that would not work at all. So again, there's a different approach that we can take with that. And the end takeaway is, irrespective of how much money you spend on test, it is still not production. Only production is production, and every release we do into an environment is a unique combination of code, the software, traffic, and data. So you can only have confidence that it will behave the way you expect it to in the environment in which you're running it. And disclaimer, just to be clear, I am not advocating for a shift right, YOLO, just do it all in production testing methodology at all. What I'm saying is there is a certain amount of confidence we can get from testing in test, but after that, gain that confidence level, get where you're comfortable with, and then start shifting that last mile to production. So we can land on a definition of testing in production then as, like, I will test, and then I will test in production. So it is not by any means just push everything into prod, which in fact, a lot of the stigma and a lot of the issues we will have trying to convince stakeholders, that's where it comes from. So the next time you see a meme that says, I test in production, respond, no, that's not helping. That's not helping at all. So then the question comes back. So if we can catch 80% of defects with 20% of the effort, well, I feel that's a generally representative set. where should we invest all the remaining effort? So maybe all of that effort that we previously would have put into manual regression or all of this other work, where should we invest that effort? Because again, quality is absolutely pivotal. That is what our users judge us by. So we want to achieve a better outcome, but with minimum or less effort. And we are far better off investing that effort in making our systems resilient to change or resilient to failure in production. Because if you think about it, the most chaos we ever inject into a production system is the code we deploy. And the thing as well, that even if we can make our systems then resilient to change, that has multiple benefits, not only for planned changes, so when we put a release out, but all of this other emergent behavior that happens in the system. So when we're sleeping in bed, do we want to get that 3 a.m. call? Or, again, can we have that work to actually, again, the system will say, that's fine, I've scaled, I remove a node, I brought another node in. Any of these things that we can now say, making ourselves more adaptive to emergent behavior in these systems. Along the same lines then, we are far better off optimizing for mean time to identification and mean time to recovery, rather than trying to prevent failure at all. When we were shipping software on CDs, that was a big issue. If there was a bug, we had no feedback loop to get an update back to the users. But now, this whole mean time between failure things, the signs that says 500 days since the last major accident, that's not helpful. Because what we don't judge from there is impact of it. And that's what I like about mean time to identification. How can we actually find the issue quickly as possible, but actually recover from it as well? So if your company is just counting the number of SEV1 or SEV2 production incidents, that is not a helpful metric. That just promotes stagnation or stability. Looking to drive down mean time to identification and recovery, that promotes productivity. And they work really well as a tension between them. So what we've just learned is, again, testing in production is actually for every single one of us, but the trick is doing it safely. And there's a bit of a barrier for entry here, and a complete disclaimer as well, that it might well require changes in your application code or approaches to be able to do this effectively. And that can be right across the entire delivery process, from how we build our code, how we test our code, how we deploy our code, and actually how we operate and debug that code in production as well. And again, what we're dealing with the systems that we're building today is moving to unknown unknowns. So it's not that we can sit down with a testing plan and sit in a room and say, we will now cover every single piece of business behavior that this application can do. Or likewise, the answer to life is 42. It is not a solvable problem. So again, how do we manage, in our approach as well, to handle these unknown unknowns or this emergent behavior? So if anyone's familiar with the QNEF framework, how do you actually get to this complex landscape? We're no longer dealing in a complicated landscape often, but again, with emergent behavior as well. And a typical approach for production systems has been monitoring. So we will, again, ask certain questions of our system. So we're going to look at the request rate, the error rate, the duration of those requests. So we'll put them on a dashboard and we'll look at them and see if they change. We just found out, though, that testing, the issue with it is that it only identifies a piece of behavior for a specific question that we ask. Monitoring is the exact same. It is dealing in a world of known unknowns. If something happens that we haven't asked the question for, you won't know about it. And don't forget, we're now tracking mean time to identification and recovery, so we actually want to be incentivized for finding these things quickly. And then if you actually take these two techniques and you overlap them, so again, in our test environments, we absolutely have all these cases, and then in monitoring and production. So the actual system behavior that we have fully covered from a pre-prod and production environment is that intersection. It's not that impressive, is it? And this is why there's been a big shift. So Charity Majors, for the keynote last year, if anyone follows her on Twitter or on social media, she's been talking about this massively. And unlike monitoring, which is something we do, observability is a characteristic of the system, a characteristic of the systems that we build, defining our ability to understand the behavior based on the inputs and outputs from that system. And that's actually incredibly powerful. Because what that would allow us to do is ask arbitrary questions of the system. So unlike monitoring, where we would have to say, at some point in the future, I want to know if this happens. So if we're actually logging production issues or we're debugging traffic, just like a metric, we didn't have to pre-cat it. And if that's not covered by the metric, we've lost the information. Observability is again, what gives us that ability to ask arbitrary questions in production, to drive down mean time to identification and ultimately recovery. And again, I'm really sorry, but there are absolutely no quick wins here. If you think you can get observability with a checkbook, it's not going to happen. And even I really feel that I'm going to say, here is instant understanding of your system, just sign up for it. That won't work. You have to put in the hard yards to instrument your systems to a certain degree as well, and then make sure that the tools you have actually are there to help grow the understanding. But the steps you have to take, there is work involved. Another key point is you need to have disposable infrastructure. So if you're dealing with pets, that's going to be a major issue for you as well. And then around the dev culture. So again, if you build it, you own it. You run it and you debug it in production. So the virtuous loop of system ownership. That's a key point from this as well. Any handoffs in this process, again, likely going to impact your ability to understand the end-to-end flow of the system. Right, so what would this look like? So testing in production is a term, but it actually comprises a whole set of techniques, and a whole set of techniques across the lifetime of a release. So we have this work that we would typically do in pre-production as well. So that would be unit tests, functional tests, static tests, property-based testing, those sort of techniques. But what we have now done is we have separated the concept of a deployment from a release. And so we're all on the same page. I count code as being released when it is receiving production traffic. You can deploy it into an environment, but if it's not receiving production traffic, then it is not released. It is just deployed. And then there's a whole range of techniques that we can do at deploy time to get confidence about it. We can run integration tests, probably quite familiar to a lot of us. Load tests. We can do some really clever things with shadowing traffic. So again, one of our big issues in pre-prod environments is we don't have access to production traffic. What if we could test a deployed service with real production traffic without impacting any of our users? And that's what traffic shadowing can give us, and we'll take a look at that shortly. Then when we're actually looking to release the code, then we can say, okay, well, how can we do canarying? How can we do, again, some monitoring of that, but again, it's not the complete solution. Feature flagging to allow delivery to pilot users. And in fact, in the release column there, traffic shifting is really the underlying capability that we need. We need to be able to route traffic on a policy basis, or even individually at the request level if we need to as well. So what we want to do here is, again, limit the blast radius of a release. So personally, I would much rather a few people back in Ireland be annoyed with a release rather than all of your user base. Right? I don't know why I picked on Ireland, but there you go. So we're going to be looking to limit the blast radius from it, and then through into production, where again, we're looking at structured logging, we're looking at events. From those structured logs, we can then build tracing. We can then build our metrics. If we start with just raw logs and metrics first, you can never work backwards. Ergo, you can never ask arbitrary questions of your system. So for the demo today, it's quite a simple application. So we have a couple of services, A and B, and we have a scenario where we want to release a new version of service C. So currently in production, we're running V1 and V2. And this is the scenario where we want to start releasing V3 of the service as well, but we want to do it in a safe way. So the first thing that we're going to do here is just show you a little bit about traffic shifting. So what I'm doing here is I'm just sending a series of requests against the current version of service C. So in this case, I've said route all the traffic to V1 of the service. So again, what we're doing with a canary release is all we're looking to do is for a certain portion of that traffic, why don't we just send that to another instance of the service? So in this particular demo, I have a Kubernetes cluster running locally on my machine, and I'm doing the traffic shifting policies using Istio. So I'm not actually going to go in depth about service meshes in this talk, but we have I think it's at 3 o'clock that Glenn Maddern's going to be doing a talk on going a bit more into detail around Istio. But what we can do is, with simple a command from here, so in this case I'm saying apply this particular policy, and it's going to route all traffic to V2. And now you'll see the requests as they're coming to the top, now being shifted back to V2. And also then if I want to say, actually just load balance across the two, so just 50-50 distribution of traffic, then that's absolutely fine. So that's one of the first cases where you'd be looking at traffic shifting. So particularly though, what we said is about, we don't actually want to send production traffic to a service straight off the bat, because we want to be able to see how would this behave with production traffic, but in a safe environment. So what we've got to do is, it is a little bit annoying that I can't show you the pictures of these, but so what we're going to do is all the traffic that goes to V1, we're actually just going to copy it. So we're going to say all the traffic that went to V1, also send it to V2. But what we'll say is V2 is actually sent in a fire and forget manner. So if that fails, the user will be completely unaware. It doesn't matter. But what this is doing is this is a way that we've actually turned deployments pretty much into a zero risk endeavor, but with the ability to look at production traffic as we go through as well. Okay, so what we'll look at here is, let me just go back to the first one, cancel that so we don't have too much noise. Okay, so what I've done for both of these services now is at the top, I've trailed the logs of V1, and in the second window down, I've trailed the logs of V2. So again, what we're going to do is we're going to send, in this case, let me actually just send all traffic to V1 to begin with. And what we'll see in this scenario is that the host header has now been defined for V1, but nothing is hitting V2 as yet. So if we want to apply a policy for that, and literally from there in mirroring, and I'll put the code up for this, but effectively everything in Istio is just walls and walls of YAML. Joy. But what we'll now see is that we have actually copied the traffic from V1 to V2, and you'll actually see in the host header that has appended a dash shadow suffix to the end as well. So this way we can still know that this isn't real production traffic, but we can see and test about it with confidence. How? 1 minute, cool. So what I'll do there is I'll give a quick example of circuit breaking as well. This is another key thing of when it's actually receiving production traffic, then how do we manage to, like, again, have the system adapt or have the response to make it resilient. So again, if there's intermittent network issues. So in this particular case, again, let's just keep sending traffic to the system. And what we're going to do in this case, we're going to say send it to all the versions. Unfortunately, what's happened is V3 keeps throwing errors. So we haven't tested that properly. So what we'll see now is when any of the requests, again, in round robin hit V3, it's throwing an error. But of course, what we don't want to do is like learn of that straight away in production and not be able to take control of it. So quite simply, what we could then do is have Istio manage that for us. So again, by applying outlier detection, the system now itself will say, if I get more than, in this case, 5 errors in a row at any point in time, take that node out of the pool. And I can do all of these policies without changing or redeploying any of my services. So to wrap up, what you've seen is that production is really a necessity. It is really the only approach that we can take to have confidence in how our code will behave in distributed systems. We've learned that observability, as well as a dev culture around end-to-end ownership, absolutely critical. So again, having infrastructure as code and having cattle, that's another entry point. We've also learned that testing in production is not just a term, it actually comprises techniques from deploy, release, and then through to production as well. So I really hope you enjoyed the talk. I'm here all day, so again, if there's any questions that you want to have, see more demos about this as well.